We're going to talk about volume and surface area. There's actually two types of surface area that we'll talk about. One of them is called lateral surface area, and the other one's called total surface area. We'll go over like what's the difference between those two. But we're going to start first by talking about volume. Volume is how much something could like hold, or how much you could fill something up with. So it's three-dimensional because you're looking at the length, the width, and the height of an object. So like a swimming pool, you would want to know how wide, how long, and how deep the swimming pool is so that you know how much water it could hold. And that could be measured in gallons or whatever. But volume has, the labels are all something to the third power. So like area was centimeters squared, feet squared. Volume is going to be centimeters cubed, feet cubed, those kind of things. So I want to go over first some of the 3D shapes that you're going to see, because this is when volume starts happening. Is instead of looking at two-dimensional shapes like rectangles and squares and triangles to find the area, we have to look at three-dimensional shapes to do volume. So the first kind of most common shape is a prism. A prism is a 3D shape that has polygons as their bases. So polygons would be like squares and rectangles and triangles and hexagons and those kind of shapes. But you've got two of them and they're parallel to each other, and the sides that go in between them are all rectangles to kind of connect those. So if you think about like a cardboard box would be an example of a prism. It's got rectangles all the way across each other, like all the rectangles are parallel with at least another one. But that would be an example of a prism. It doesn't have to actually be a rectangle for the base, like it could be a triangle. So like there are triangular prisms as well. But these are kind of what they look like and some of the main pieces of them. So they've got some things kind of labeled for you, like where your bases are, where your lateral edges and lateral faces would be. Now cylinders are kind of like a prism, except instead of having rectangles as the sides, a cylinder has a curved surface that goes around it. So think about any canned food item. Okay, canned fruit, canned vegetables, canned whatever. That's all in a cylinder shape. It has circles for its bases, and the outside edge is like a curved. It's basically, if you laid it out flat, it is a rectangle, but it's curved around that circle shape. Cone has a base of a circle, and it still has a curved side, but it kind of comes to a point, which is called your vertex. So instead of having two circles, it only has one. And so the kind of lateral face of it is going to come to a point at the very top or at the bottom. And pyramids do the same thing. Pyramids are a little bit more like prisms, though, because they actually have faces. On a pyramid, though, all the faces are triangles instead of rectangles. Then the last shape that I have on this page is a sphere. Okay, sphere would just be a three-dimensional ball. So like a basketball, a golf ball, soccer ball, anything like that. And inside of a sphere, like if you cut it in half and you look at what happened when you cut that. So if you cut a ball in half, you'd have two circles. Okay, so it causes you to have like hemispheres. So think about like the Earth. If the Earth is cut in half, it's a circle there. So that's why we have the northern and the southern hemisphere. They break it into two parts. Spheres have radiuses, diameters, chords. They have all those same pieces that circles have. So these are the formulas that you're going to want to be using when you're trying to find volume. Prisms and cylinders share a formula, just like cones and pyramids share a formula. So if you have a prism or you have a cylinder, you're going to use the same formula, capital B times H, where capital B represents the area of the base shape. So for like a prism, you'll have to figure out what the base shape is, whether it's a rectangle, a triangle, or something like that, to find the area of that shape. For a cylinder, the base is a circle, so you'll have to find the area of a circle. And then height. Height is not talking about height of the base. Height is talking about height of the shape, height of the 3D shape. So like, what's the space between your bases? So if I was looking at my filing cabinet over there, the top and the bottom would be my bases. If I wanted to know the height, I'd have to measure how tall the filing cabinet is, how much distance is in between the top and the bottom of the filing cabinet. Cones and pyramids also share a formula. And again, you'll have to figure out what your base shape is. For a pyramid, the base shape can change. It can be a rectangle, it can be a square, it can be a triangle. A cone is always going to have a base of a circle. And then again, height is talking about height of the cone, height of the pyramid. Now we have something on cones and pyramids called the slant height, because if you think about a cone or a pyramid, it goes down at an angle. So we have something called a slant height there, and you'll see that get used too when we start talking about surface area and that kind of stuff. And then sphere, you just have one formula for the volume there. You have to use the radius, just like you had to use radius to find area of a circle, you have to use radius to find volume of a sphere. So let's do a couple of examples here. All right, first one here wants us to find the volume of this triangular prism. So since it's a prism, I'm using the formula capital B times H, so the area of the base times the height. So let's talk about the area of the base. So I'm going to find capital B first. Now this is calling it a, if you read up here, triangular prism. Prisms are named using their bases. So when they say triangular prism, they're telling you that the bases are the triangles. So if you look at your shape here, the triangle on the top and the triangle on the bottom, those are your bases because they're parallel from each other. The bases should always be parallel and should never ever cross. The rectangles are the sides, okay, and they're not parallel to each other. So for my triangle here, to find the area of a triangle, you have to do 1/2 times the base of the triangle times the height of the triangle. Not the height of the prism, the height of the triangle. So if you guys look at the triangle shape that I have outlined in red, what's the base of the triangle? 3. What's the height of the triangle? Nope, that's the height of the prism. Nope. The 2.6. The 2.6 is pointing to the line that's going up and down inside the triangle, because the triangle's height has to be a perpendicular segment. It can't be a slanted side. So 2.6. Okay, so if we calculate that, if we take half, or take 3 times 2.6 divided by 2, and I round it, I'm going to get 3.9. So that's what capital B is equal to. That's not the volume of this prism, that's just the area of the base. So now going back up here, my height for this prism is the 15 centimeters. So these are the two numbers that I need to use, 3.9 and 15. So I'm going to take the volume of the area of the base, 3.9, times the height, which is 15. So then we take 3.9 times 15. So then we get 58.5. And then labeling, make sure you're labeling your answers, centimeters cubed, because we're talking about volume now. Make sure, like I said, that you guys can differentiate what's the height of the base shape and what's the height of the actual 3D shape, because they're different. If you use the 15 for the height of your triangle, your answer is going to be off. So you want to make sure that you can tell the difference between those two things. So the next one in your guys' packet is a cylinder. We're going to use the same formula. Okay, volume of a cylinder and volume of a prism are the same thing. So we're going to do volume equals the area of the base times the height. Now what shape makes up the base of a cylinder? A circle. So when you guys are finding B, you're basically trying to find the area of a circle. What's the equation for area of a circle? It's in your packet, like last section when we talked about circles. That's circumference. Pi r squared. On the picture, guys, what's that 5 inches referring to? The diameter. So don't use that for r. What do we have to do to the 5? Divide it by 2, okay? So this 5 here is the diameter. So we need to take 5 divided by 2, which is 2.5. That's going to be my radius. So in for area now, I'm going to do pi times 2.5 squared. Okay, so we're going to multiply that. So we get 19.6. That's me rounding it. Okay? Now, what's the height of the cylinder? 4 inches. Okay, so now we take the 19.6 and the 4 inches and we find the volume. 78.5? Is that what you said? How would I label it? Good, inches cubed. Now there might be some problems that don't give you a picture of the shape, okay? And so we have to kind of read and decipher what's happening here. So on this next one, it says to find the volume of a pyramid with a square base that is 15 centimeters on a side and has a height of 28 centimeters. So volume of a pyramid, if we go back to the previous page, that formula is 1/3 times the area of the base, capital B, times the height of the pyramid. Now they tell you in the problem that this pyramid has a square base. That means that the base shape is a square. So when you guys are trying to find B, capital B, you're trying to find the area of a square. How do we find area of a square? How would you find like area of a rectangle? Length times width. So squares have all equal sides, so you're just taking a side times itself, or a side squared. How long do they say the sides are on that square? 15 centimeters. So what you're going to do for the area of the square, because it says that it has a square base that is 15 centimeters on a side. So the square is 15 by 15 by 15 by 15. We're going to do 15 squared, which is what? $225. Now I need the height of the pyramid. What did they tell you the height is? 28. All right, so now let's plug these in to our volume equation. We're going to take 1/3 times 225 times 28. You could also take 225 times 28 and then divide by 3 if you don't like the fraction. You can do that also. Anyone know what we get there? Good, 2100. And this would be centimeters cubed. Why don't you guys try number 4? It wants you to find the volume of a sphere. So write down your sphere volume equation. Be careful and make sure that you're using the radius. This one tells you that you have a diameter of 90 centimeters. All right, so we are using the equation 4/3 times pi radius to the third power. Okay, what's the radius for this problem? 45, because the diameter is 90, so you have to take 90 and divide by 2 to get 45 centimeters for the radius. So we're going to take 4/3 times pi times 45 to the third power. You get a big number. Anybody know what it is? All right, 3, you said 703? 510? Yep, 703.5. So if you wanted to round it to the nearest whole number, it would probably go up to 04. All right, so that would be centimeters cubed. If you don't like the fraction, okay, because I know some students, like on pyramids, cones, and spheres, they hate the 1/3 and the 4/3. Here's what you could do instead of calculating with the fraction. Like for the first one, like I said earlier, you could take 225 times 28 and then divide by 3. That's the same thing as multiplying by a third. For 4/3, you could take 4 times pi times 45 to the third and divide all of that by 3. If you don't like using a fraction, okay? You don't have to do that, but if you don't like to calculate or you don't like to type in a fraction, you don't necessarily have to. All right, underneath that, I've got something called the frustum of a pyramid, which basically is when you have a pyramid and you kind of like cut off the top portion, you almost get like this three-dimensional trapezoid type shape. Okay, so what we're talking about is finding the area of that space. So it says it's a part of the pyramid between the base and a plane passing through the pyramid that's parallel to the base. So it kind of is just cutting off the top of the pyramid, and you're trying to find the volume of that bottom space. So this is the formula that you want to use for that. 1/3 times the height of the pyramid, and then they have B1 and B2. Those are talking about area of your bases. So the bases would be like the top and the bottom of that trapezoid type shape, that 3D trapezoid. And then H is still the height of the pyramid. So let's do an example here so you can kind of see how this would work. So I'm going to keep the formula right there for us so we can see it. So find the volume of the frustum of a pyramid with a square base that is 4 inches on each side and a square top that is 2 inches on each side. And the height is 3. So both of our bases are squares, so we need to find the area of both of those by doing our side squared again. So to find base 1 and base 2, I'm going to take the sides of my squares and square them. So one of them has 4 inches on each side, so 4 squared would be 16 for one of the areas. The other square, it says, is 2 inches on each side. So that would be 2 squared, which is 4. And then they say height is 3. So we're going to plug this into our formula now. So 1/3 times the height, which is 3, times base 1, which is 16, plus base 2, which is 4. We're talking about the area of those bases. And then plus the square root of 16 times 4. Now this one has quite a bit of stuff happening, so I would just try to follow your order of operations, break this down piece by piece if you need to. All right, what is going to be 1/3 times 3? 1. Okay, so I'm just going to go ahead and cross those off if you guys are okay with that, because that's just a 1. What's 16 plus 4? All right, so I've got 20 plus, what's 16 times 4? 64. Now that's underneath the square root sign, So what's the square root of 64? 8. So I'm going to take 20 plus 8, and I'm going to end with 28, and this would be in inches cubed. There will be some problems like this where they actually just tell you what the area of the bases are. So you may not have to find the area of the bases. For this one we had to, but they're squares. Finding area of a square isn't too bad. You just have to take the side times itself. Now in a previous section, section 2, when we were talking about polygons and we were going over area for like your 2D shapes, we got into those composite shapes where we had to kind of break them, split them in half so that we had 2 smaller shapes and then we added the areas together. They can do the same thing when it comes to volume. Okay, so we want to find the weight of this cast iron object, and they're telling us that cast iron weighs 0.26 pounds per cubic inch. So we have to find the volume first and then figure out what it's going to be in pounds. Like how much is it going to actually weigh? Now this is a complex shape here because we've got kind of different pieces to it. I would actually break this into 3 shapes. What 3 shapes do you think I'm going to break this into? A cone. Okay, so a cone, a cylinder, and not quite a full sphere, but I'm going to do a half or a hemisphere. Okay, so the bottom is just going to be half of a sphere or a hemisphere. So I'm going to break this into, I'm going to find the volume of a cone. Then I'm going to add it to the volume of a cylinder. And then I'm going to add it to the volume of a hemisphere. Let's start with the cone. Cone is at the top here. Volume of a cone's equation is 1/3 times the area of the base times the height. So a base of a cone is what shape? Circle. So I'm going to take the area, I got to find the area of that circle. Now on the bottom, you see where it says 9 inches? On the bottom there? That is the length of the circle all the way across. So that's its diameter. So what would be the radius of this circle? 4.5. Okay, so for the volume of a cone, I'm going to take 1/3 times area of a circle is pi radius squared. And you guys said that the radius is 4.5, right? So we're going to do pi times 4.5 squared. What's the height of just the cone? 8 inches. All right, so let's do this calculation. If you have a calculator, take 1/3 times pi times 4.5 squared times 8. When you do that, if I round it, you should get 169.6. Now let's move on to the cylinder. Volume of a cylinder is the area of the base times the height. Now cylinder has circles again, okay? So the same circle that we were using on the cone is on the cylinder as well. So where you guys see in the cone formula, pi times 4.5 squared, you're going to have to use that again for the same base because the base is the same. So we're going to do pi times 4.5 squared. What's the height of the cylinder piece? 10. Okay, so let's type that into our calculator. Pi times 4.5 squared times 10. So if you round it, you should get 636.2. Okay, last shape is a hemisphere. Now I gave you the equation for a full sphere. I said that that was 4/3 times pi r to the third. So if that's for a whole sphere, what do you think you need to do to that to find the area of a hemisphere? Divide by 2. So what I'm going to do is after I find this, I'm going to divide by 2. Because I'm taking that sphere and I'm cutting it in half. Now the sphere, you know, a hemisphere like we talked about has a circle there. So you still need to figure out the area of that circle, or at least the radius of the circle, which we've used in the previous two formulas. What did we say the radius is for those shapes? What number is the radius of my circle? 4.5. So 4/3 pi times 4.5 to the third power. And then we're going to divide that by 2. So don't try to do this all in one step if you think that you're going to get that mixed up. So I would take 4, either do 4/3 or multiply by 4 and then divide everything by 3. So 4/3 times pi times 4.5 to the third power. And then cut that in half. So divide by 2. That should give us 190.9 if we round. Okay, so can someone add up those numbers and tell me what you get? Good. And so this would be inches cubed. This is the volume of that shape. Now they want to know how much is it going to weigh. So per cubic inch, so for every 1 cubic inch, it weighs 0.26 pounds. So what we need to do to figure out the weight of this shape is to take our 996.2 or 0.7 and multiply by that 0.26. This is going to tell us how much it's going to weigh in pounds. Now they want it to the nearest whole pound. So when you guys multiply by 0.26, you're going to get a decimal. I want it rounded to the nearest whole pound. What are you guys going to give me as an answer? Good, 259 pounds.